Problem sheet 1, question 1. Apples falling off a tree randomly in time can be described as a Poisson process with rate lambda equals 2 apples per day. A. What is the probability that less than 3 apples fall in a day? So what random variables are we dealing with here, and what do we know about? Well, we are considering the number of apples that fall in a day, and as that follows a Poisson process, there's something we can say about that. So consider the random variable xd, which is the number of apples fallen in a day. We know that that is Poisson distributed with rate lambda equals 2 apples per day. What does that mean? Well, we know that that means that the probability of xd being equal to some specific number n, so that is the probability that there are exactly n apples fallen in a day, will be equal to lambda to the power of n e to the minus lambda divided by n factorial. Now the question is asking, what is the probability that there are less than 3 apples in a day? So that is asking for the cumulative distribution. So what do we know about the probability that xd would be less than a particular number n? Well, that is going to be summing up all the probabilities of xd being any integer less than n. So that is equal to, from k equals to 0 to n minus 1, the probability that xd is equal to k. In this case, we care about the quantity, or is the probability that xd is less than 3, that is that there are less than 3 apples in a day. That is equal to the probability that no apples fall in a day plus the probability that 1 apple falls in a day plus the probability that 2 apples fall in a day. And from this we can just use the formula for each of these entities. So we can say that this is equal to lambda equals 2 to the power of 0 e to the minus 2 over 0 factorial plus 2 to the power of 1 e to the minus 2 over 1 factorial plus 2 to the power of 2 e to the minus 2 over 2 factorial. This is just something we can plug into a calculator, and we eventually get the answer of 0.67667. Question B is asking, what is the probability that less than 3 apples fall in a week? So now we need to consider a different random variable. We now need to consider xw, which we will define as the number of apples that fall in a week. Now we know that apples falling off a tree randomly in time can be described as a Poisson process, and we know that if we care about the time interval of a day, we have lambda equals 2 apples per day. So what do we know about xw, the number that fall in a week? Well, that is also Poisson distributed with lambda equal to, well, if we know that 2 apples fall per day, then that rate is the same as saying that 14 apples fall in a week. 7 days a week, 2 apples per day. So the rate is the same, is constant throughout the week. So the rate now is 14 apples per week. Okay, so now we can ask, what is the probability that xw, the number of apples that fall in a week, is less than 3? Well, it's going to be the probability that no apples fall in the week plus the probability that 1 apple falls in a week plus the probability that 2 apples fall in a week. The formula is the same as before. Now instead of considering 2 apples per day, we're considering 14 apples per week. So we can say that the probability of no apples falling a week is going to be lambda, which is 14 to the power of 0 times e to the minus 14 over 0 factorial. 1 apple per week would be 14 to the power of 1 e to the minus 14 over 1 factorial, and 2 apples per week 14 to the power of 2 e to the minus 14 over 2 factorial. This is something we can plug into a calculator and we get the answer of 0.00018. It's a very small probability. Question C asks, what is the average time between 2 consecutive apples falling? Well, the only information we have is that the number of apples falling off the tree is Poisson distributed. But we also know that the time between any 2 Poisson events is exponentially distributed. So if we define t as the time between 2 consecutive apples falling, then we know that t is going to be exponentially distributed with rate lambda is equal to 2 apples per day. If t is measured in days, we could easily also have gone t is exponentially distributed with lambda equals 14 apples per week if t was measured in weeks. So let's go with t measured in days. And the average time between 2 consecutive apples falling then would be the expected value of the variable t. And the expected value of an exponential distribution is 1 divided by lambda. So in this case, it's 1 divided by 2, which is half a day. Finally, question D is asking, what is the probability that I wait longer than 12 hours for an apple to fall? Now, 12 hours is half a day. So that is the same as asking the question, what is the probability that the time between 2 consecutive apples falling is longer than half a day? Now, what do we know about the exponential distribution? As a side, we know that the probability of t being equal to some value t, if t is exponentially distributed, is lambda e to the minus lambda t. That is the PDF. And the CDF, the probability that t is less than some value t, is 1 minus e to the minus lambda t. I'll just keep that up. The probability of t being greater than a half is equal to 1 minus the probability of t being less than or equal to a half. So that is 1 minus, and the probability of t being less than or equal to a half is just the CDF of t. So that would be 1 minus e to the minus lambda t, lambda in this case being 2, and the t that we care about being a half. So this would be equal to e to the minus 1, which we can plug into a calculator and get the answer 0.36788. Now there is an alternative way to answer this final question, D. Rather than considering the time between consecutive apples falling, we could still consider the Poisson distribution. So let me show you that. So consider the variable I'm going to call it x subscript 12 now, which is the number of apples that fall in 12 hours. What do we know about this? Well, this is again Poisson distributed with a rate. If 2 apples fall per day, which is 24 hours, then in 12 hours we expect 1 apple to fall per day. Now, the probability that I wait longer than 12 hours is going to be the probability that no apples fall in 12 hours. So I can use the Poisson formula. Let's remind us of the Poisson formula. The probability of x being equal to n is lambda to the n e to the minus lambda over n factorial. We can use this formula to say that the probability of x in 12 hours being equal to 0 is going to be lambda, which is 1 to the power of 0, e to the minus 1 over 0 factorial, which turns out to be e to the minus 1, the same answer as before, which is 0.36788. So 2 different ways of answering the same question there. One using the exponential distribution for the time between 2 consecutive events, and one using the Poisson distribution.